Greetings. Today we'll be doing the problem that will be from probability. A problem says a bag contains 7 yellow balls, 3 red balls, 2 yellow balls. A ball is chosen at a random from the bag and is not replaced. So here a second ball is then chosen. So the problem says that here we are required to determine the probability that of the 2 balls chosen, one is red and the other is blue. From the information given to the question, here is the information given to us. We are given that we have 7 yellow balls. We have 3 red balls. And we have 2 blue balls. So if we want to find the sample space, the total number of balls is 12. Alright, so when we work with the probability, this is how we write a probability. Yellow balls, so a probability of yellow ball is equal to 7 balls out of how many balls? Out of 12 balls over 12. And the probability of having a red ball is 3 balls out of how many balls? 12 balls. So 3 over 12. And the probability of getting a blue ball is, how many balls do we have that are blue? Are 2 out of how many? Out of 12. So it is 2 out of 12 balls. Okay, at the moment, we don't necessarily need this one because the question only requires us to find red and blue balls. Okay, so if we come along with a scenario like this, we work with a tree diagram. How is the tree diagram going to look like? Here is the tree diagram. How many colors are we working with? We have red and we have blue. I said to you, the probability of getting a red ball is 3 over 12. Meaning here you write 3 over 12 as your probability. And the probability of getting a blue ball is 2 over 12. So here we have 2 over 12. Alright, on the information that was given to us, there is a key that was there. What is it that was there? They told us that once you pick a ball, you don't replace it. So balls are not replaced. Alright, what does that mean? That means that if the total number of balls were 12, once you pick one, meaning you now left with 11 balls. Alright, so now you are picking a second ball, because picking the ball for the first time, it's either you pick the red ball or a blue ball. And picking the ball from the second time, provided that you pick the red ball at the beginning, now you still have how many balls? You still have red and blue. Okay, so here in red and blue, if you picked red, meaning number of red balls, they are no longer 3, but they have been reduced into being 2. Out of how many balls? 11. Remember, I did emphasize that once you pick a ball, you don't replace it, meaning even the sample size is reducing. So it has reduced by 1. And the number of red balls has reduced by 1. Bear in mind that you haven't done anything on the balls that are blue. So meaning the probability of picking the blue ball, we said how many blue balls do we have? Is 2. But it's no longer 2 over 12 because 1 ball has been reduced. Meaning the sample space is no longer 12, we're now working with 11. So it is over 11. Alright? Or else maybe you pick blue ball and the second one, it's either it becomes red or it becomes blue. So bear in mind that you picked blue ball. If you pick blue ball, meaning red ball was not affected. So the probability of picking the red ball now will be what? We said the probability of picking red ball is 3/12. But due to the fact that there is a ball that has been chosen, of which is blue, meaning the sample space is no longer 12, is now 11. That is why here we'll be left with 3/11. And here, if the ball was blue that was chosen previously, meaning the second one would be what? Would be having this probability. All right, so this is what we need. Here we have a probability of red and red. Here we have a probability of red and blue. Here we have a probability of blue and red. Here we have a probability of blue and blue. Okay. Here you have to pay attention. We are picking two balls, one is red, one is blue, but order doesn't matter. Meaning, out of all these probabilities, our main aim is to work with the probabilities that has red balls and blue balls, irrespective of the order. So how many probabilities consist of red and blue balls? So if you can look carefully here, here is the probability. Here we are talking of red and blue. And here is red and blue. But here it's red and red, meaning we omit this one. Here it's blue and blue, meaning we omit this one. So the summation of these two probabilities is what gives us the solution to what the problem that was given to us. All right. So a probability of picking red and blue is probability of picking red times probability of picking blue. All right, here, don't make a mistake of writing these two probabilities when you multiply here. This thing says this to us. You picked the red and then you picked blue. Meaning the probability of blue that you will be using here is the probability of 2/11, not the one of 2/12. Here. So meaning we'll be having this 3/12 multiplied by 2/11, which gives us 6/132. And then we move to this one. The probability of blue and red. So it's a probability of blue multiplied by probability of red. Remember, we are now on this side. So the probability of blue here is this one. So we'll be having 2/12 times the probability of red is this one, not this one, but this one, of which is 3/11, which gives us 6/132. So if we sum the two, of which is the probability of red and blue plus probability of blue intersection red, it will be equal to 6/132 plus 6/132, which is equal to, when you add the two same denominator to 132, we add the 2, so we'll be having 12/132. So to divide the 2 will be 6. If you divide this one by 2, it's 50, 100. If you divide the 2, 16. So 50 plus 16 becomes 66. So if you divide by 6 here, I'll end up with 1/11. So this is the solution to what the problem that was given to us. Thank you. I'm looking forward to see you in next videos.